given this equation, 2 raised to the power of x times 3 raised to the power of x squared equals 6, then our goal is to find all possible values of x that satisfies this equation. By the way, x here is a real number. Now, pause this video right now and see if you can answer this question. And of course, if you're done, post your answer in the comment section down below, because I will show you the solution in 3, 2, 1. So given this equation, 2 raised to the power of x times 3 raised to the power of x squared equals 6, the goal is to find out all possible values of x, real values of x that satisfies this equation. Alright, so what we're going to do here is to make all these bases be equal to 3. Why not? You can use 2, you can use 6, but in this video, I will choose 3. Alright, and to do that, we will use this identity. If we have b raised to the power of logarithm of n to the base of b, we have the same base. This is just equal to n. So this 6, we can rewrite this in the base of 3 as 3 raised to the power of logarithm of 6 to the base of 3. So this is just 6. Right? Now how about this 2? We can rewrite this using again this identity. 2, we can rewrite this as 3 raised to the power of logarithm of 2 to the base of 3. Now, what we're going to do is to multiply this x to logarithm of 2 to the base of 3. And then, what we're going to do is to combine these two exponents because, again, we have the same base. So if we have the same base, b raised to the power of a times b raised to the power of c, we can take the base and add its exponent, or a plus c. So the left-hand side of our equation is just x 3 raised to the power of x times logarithm of 2 to the base of 3 plus x squared. Now, we have equal expression and equal bases, therefore their exponent must be equal. So we have x times logarithm of 2 to the base of 3 plus x squared equals logarithm of 6 to the base of 3. Now, let's focus on this result. Now, focus on this 6, because the 6, we can rewrite this as 2 times 3, for sure. Now, why we do that? Because we will use this identity. If we have logarithm of a times c to the base of b, we can rewrite this as logarithm of a to the base of b plus logarithm of c to the base of b. So, the right-hand side of our equation, we can rewrite this as logarithm of 2 to the base of 3 plus logarithm of 3 to the base of 3. Now, focus on this expression, because take note, logarithm of b to the base of b is just 1. So logarithm of 3 to the base of 3 is just 1. And the rest is bring down. Now let's focus on this result. Next, what we're going to do here is take note, we have here a common term, logarithm of 2 to the base of 3. So maybe we can factor this out later. So let's equate this to 0. That's the first step. And we can now factor out the common factor, logarithm of 2 to the base of 3. And if we do that, we get logarithm of 2 to the base of 3, the common factor, multiplied by x minus 1. Alright. And the rest is bring down. Now, x squared minus 1, or simply equal to 1 squared, we can factor this out using the difference of 2 squared. So, x squared minus 1, we can factor this out as x plus 1 multiplied by x minus 1. Now, notice, we have a common factor of x minus 1. So, we can factor this out nicely. So, the remaining term is logarithm of 2 to the base of 3 plus x plus 1 multiplied by the common factor x minus 1. Now, let's focus on this result. And then, since it is equal to 0, so using the 0 property, at least one of them must be equal to 0. We can say that logarithm of 2 to the base of 3 plus x plus 1 equals 0, or x minus 1 equals 0. Now, let's do this case because this is very simple. X minus 1 equals 0. Add 1 on both sides. We get that x equals 1. So, x equals 1 is definitely one of the possible solutions to this equation. Because using observation, 2 times 3 is just 6. So, x equals 1 is definitely one of the possible solutions. But there's one more. Here it is. If we solve for the value of x in this case, the first case, we get that x equals negative 1 minus logarithm of 2 to the base of 3. This is enough. This is the answer, but we can simplify this using a single logarithm, because this one, we can represent this as logarithm of 3 to the base of 3. Now, factor out -1, logarithm of 3 to the base of 3 plus logarithm of 2 to the base of 3. If we combine this, we have logarithm of 6 to the base of 3. So the second value of x is negative logarithm of 6 to the base of 3. So we found out two different values of x that satisfies this equation. And of course, we need to check if these two values really satisfy the given equation. And let's do the checking. And here it is. If x equals 1, definitely 6 equals 6. And if x equals negative logarithm of 6 to the base of 3, you can pause this video right now and see the checking process. And as you can see, we end up with 6 equals 6. Therefore, given this equation, 2 raised to the power of x times 3 raised to the power of x squared equals 6, then we found two real values of x that satisfies this equation. The first one is negative logarithm of 6 to the base of 3, and the second one is x equals 1. And as always, we are done.